Welcome. In this video, I'm going to teach you how to use the washer method to find the volume of a torus. So a torus is like a donut. It is a donut with a circle in the middle, with a hole in the middle. It's a donut. Basically, it's a donut. So okay. So the way what I do it is that I'm going to rotate about the y-axis, and I'm gonna call the radius r, big R, from the center of the torus towards the middle of the torus, middle, and then from here to here I'm gonna call it small r. So the washer method is an extension of the this method. So the volume is equal to pi of this torus will be, because I'm going from here to here, I can call it negative r to r of the outer radius, outer square minus inner radius square dy. You can call this one like that, r square of y minus little y square. Okay, so the volume is equal to pi from negative r to r. Okay, notice, because we have a circle, we can show that x squared plus y squared is equal to r squared. That's the function of a circle, of the outside of a circle. So if I want to get I'm going to solve it in terms of y, because we're going to do a horizontal slab from here to here. That means that I have to solve this one for x. So this becomes x is equal to r squared minus y squared. Okay. Okay, notice, what's the position here? From here to here is r. So from r, we need to add the outside, which is this here, the position of the outside. The length of the outside, so that will be from the middle to the outside, so that will be r plus this one, r squared minus y squared. This whole thing I squared minus okay, now I go from here to here, but I don't want this piece. So what I'm gonna do is I'm gonna take r and I'm gonna subtract this piece. And what's this piece here? Is this again. So it will be r squared minus y squared and square dy. Notice, because I have symmetry, I can, here basically I'm computing half of the circle. So what I'm going to do is I'm going to get rid of this negative r. Because of symmetry, I'm just going to do 2 pi from 0 to r, and then I FOIL this. That would be r squared plus 2 r squared minus y squared plus r squared minus y squared. And this will be minus r squared this here. That will be plus 2 r squared minus y squared. This will be minus r squared plus y squared. This whole thing dy. So now I cancel like terms. So this, and I'm left with 2 pi from 0 to r of 2 r squared minus y squared dy. Now what I do, I pull out the 2, so that will be 4 pi 0 to r of r squared minus y squared dy. Notice, before we had half, now we have only a quarter of the area of a circle. So what I'm gonna do is, because this is 2, actually this is 2 plus 2, this actually is 4. This becomes 8. Okay, so now, because this is a quarter of a circle, quarter of circle area, what I'm gonna do is 8 pi times 1/4 pi r squared, and that gives me the volume, which is so 8 divided by 4, that's 2 pi, and remember, oh yeah, I forgot this. Okay, here, because we are multiplying r times r, that this will begin, this is 2r, this is 2r, and then this is r, so r here, so then this becomes, so the final formula is gonna be 8 gets divided by 4, so that's equal to 2, then pi times pi, that's pi squared r, and then r squared. So that will be the volume of the torus. Okay, so let's see, pi squared 2r squared. Don't forget to subscribe, please. Thank you very much.